Well, good afternoon, everyone. Thank you for coming. My name is Nathanael Tinik, and the title of my thesis is Examining the Factors Associated with Recidivism. So to begin, I kind of wanted to talk about the motivation I had for taking on something like this and doing a regression analysis, and also why I decided to choose a topic like recidivism. And it all started back a year ago, last spring. We had a class called Statistical Modeling 1, and which is a major requirement for all actuarial science majors. And in it, we learned more about statistics, hypothesis testing, confidence intervals, and also linear regression. And up until that point, it had been one of the most interesting classes I had. I liked learning about manipulating data and learning how to use the data to predict something else. And so when it came time to start thinking about what my thesis should be, I automatically knew I wanted to do something with some kind of regression. But to narrow down the topic of recidivism, there are several reasons I chose that as well. And the first is current societal problems. In society today, the International Center for Prison Studies has found that the United States has the highest prison population rate in the entire world, which is nearly 716 out of every 100,000 people in America are incarcerated, which doesn't seem like that many people. But when you apply it to the entire population, that's nearly 3 million people who are incarcerated. And that also causes a huge burden on taxpayers. According to Business Insider, the total prison expenditures cost the American taxpayers roughly $39 billion, which is a huge sum of money that I'm sure could be spent more efficiently elsewhere. Another reason I decided on this topic was because of the contemporary studies I was researching. A lot of them tended to focus on one variable versus recidivism, such as age versus recidivism, or gender, or so on and so forth. But I wanted to combine the variables and see how they affected recidivism together. Like, instead of just one, I looked at multiple. And the last reason was because I had the data was easily accessible. Now, it was accessible to everyone, the data I got. But I got the data from my sister-in-law who works with the Pennsylvania State University in the Pennsylvania Commission on Sentencing, or the PCS. And the PCS is the department that produces the data for all sentencing data, but it's actually the Inter-University Consortium for Political and Social Research located in Ann Arbor, Michigan, that distributes all the data. So anyways, the data I have is Pennsylvania sentencing data from 1998. So keep in mind, all of the results I have are just strictly a snapshot of 1998 and all crimes committed before then. There's no looking into the future or anything like that. It's just a perspective from 1998. And this data is based on 1991 and 1994 sentencing guidelines, which the PCS develops these guidelines and sends them to judges throughout the state. And when a judge fills out this form when sentencing a criminal, they send it back to the PCS, who compiles all of the data. And so the particular data set I have consists of 32,744 cases with 15,746 unique individuals, which means that when these individuals were being sentenced, they were being sentenced, the majority, for multiple crimes. So now to take a look at the model I used. A typical linear regression model would not work here, but my advisor, Dr. Hudak, and I found that a logistic or a logit regression model would work. And that uses a qualitative binary response y. And what that means is y can only take the values 1 and 0. And in this particular analysis that I did, y is equal to 1 if the individual has a prior conviction on their record, or y is equal to 0 if they do not have a prior conviction. And then this formula here is the basis of the model. So the expected value of y is equal to the probability that y equals 1. And as you can see, it is not a linear model. It's e raised to the sum of the products of the coefficients times the variables divided by 1 plus e to the sum of the products. And taking a look at the independent variables I was researching, first is age, gender, which takes the values male or female, race, which takes the value Caucasian, African American, or other minorities, and then so forth. The county, less than 50,000 in the population, between 50,000 and 200,000, or greater than 200,000. And then the last variable that I had access to in the data was drug dependency, and that was either the individual was drug dependent, was not drug dependent, or there was no assessment completed. And so here's a more detailed look at the variables. X1 is the first variable, which is age. It is quantitative in nature. You just enter your age in. But X2 through X8 are special. They're qualitative variables, which means I had to use a dummy variable. And it's because the original variables, the gender, the race, the population, the drug assessment, are all qualitative in nature, which means I had to use dummy variables. And so that takes the value 1 if the condition is true, or 0 if the condition is false. Okay. And so using the statistical software R, these are the results that I discovered. And so if you take a look at the second column, titled estimate, these are actually the coefficients. If you remember in the formula, these coefficients are the betas used in the equation. And so a positive number indicates that it has a positive impact on the value of y, and a negative number indicates a negative impact on the value of y. And also, the larger the value, the greater the impact it would seem to have. So as you can see, X2, which is male or female, has a greater impact. And then if you look towards the end, the last two, this just describes the level of significance. 5 of the 8 variables were statistically significant at a level of 0.001. And to be statistically significant, it doesn't actually mean it's like meaningful or important. It just means that we were unlikely to get these results purely by chance, which means they have some influence on the response variable. To put it into perspective, statisticians typically use a level of 0.05, and using that level of significance, 7 out of the 8 variables would be significant. And just for fun, this is kind of my experiment based on the results I got. And so I decided to use my own data. So I'm 22 years old, male, Caucasian, so on and so forth. And I input it into my regression equation. And so if I was a record in the 1998 data file, the probability that y is equal to 1, which means that the probability that I would have had at least one prior conviction was roughly 33%. Which isn't too bad, I guess. So anyways, I found the project to be very worthwhile in doing. One of the biggest rewards was taking something that you've learned in class, getting to apply it to a real world example, and get to see the results. So thank you. Do anybody have any questions?